This video is to help with homework from Maple TA, Lesson 8B. The first thing it's asking for on question 1 is for finding the function f of x equaling 9x minus 4 and evaluating it for each of these following numbers. F of 1, that means that I need to replace every time I see x with a 1 and so forth. To do this, I always put parentheses around wherever I'm substituting so that I don't get mixed up with any of those negatives. Here's my quick reminder, but I'm going to show you some work over here, and this is what I will be going through. So I want f of 1. So every time I see 1 in the function, I will put parentheses around that x and put a 1 to replace it or substitute. And then we'll go through and solve that in a minute. So I'll set this up just by typing that in. I want f of 0. That means I want 9. Actually, because we're using computer, I'm just going to copy and paste this down here and replace that with a 0, making sure that I have parentheses around everything. In fact, to speed us up, we'll just do that each time too. 4 more. 1, 2, 3, 4. Okay, and then we will just replace this with -1, -1, 2, 2, -2, -2, and the last one is 5. The key with this one is making sure that every single time you see an x, just automatically think parentheses around wherever that x is so that you know that it's going to be, that you don't accidentally think that it's something like 9 minus 1, but that you're actually getting the multiplication in there. So our first one, 9 times 1 is 9, minus 4 gives me 5, and I'll type 5 over here. Over here, 9 times 0 is 0, minus 4 is -4. Make sure that you're also doing the order of operations on some of these that might get a little larger. 9 times -1 is -9, minus 4 gives me -13. 9 times 2 is 18, minus 4 is 14. 9 times -2 is -18, minus 4 is -22. And 9 times 5 is 45, minus 4 gives me 41. And we'll type those numbers in over here, if we can see them still. If you wanted to use Microsoft Excel for this, you could have done that as well to kind of speed things up if you wanted to, but I wanted to walk through this with you so that you saw every single step. Just typing these numbers in. I hope I did all of my mental math quickly and correctly. Sometimes doing it auditory, I make mistakes. So if you see a mistake there, let me know. I guess we could do that. How did I do? Yep, we got them all done. Okay, let's move on to question number 2. Simplify this expression. So again, I'm going to show you using Microsoft Word. I'm going to come up here and insert an equation just because it makes it nice to see. I can set it up with a fraction and use my exponents, but it also understands how to do that with just typing it in. So I'm going to go ahead and start with parenthesis 4xy, close parenthesis, and raised to the 5. Pressing the space bar makes it look nice. Then I want to divide by x to the 3rd, x raised to the 3rd, pressing the space bar raises it to the 3rd, and then I'm going to press the space bar again and it'll make it look more like a publishing. So on the top I have that entire thing being raised to the 5th. So I have 4xy 5 times, and I could rewrite that as, I could come over here and just show that it is 1, 2, 3, 4, 5. I'm multiplying that 5 different times, and I can go ahead and write it out. It's longer, but it will work, and it will always be one way to remember how to do the rule. that means I have 4 times 4 times 4 times 4 times 4, which is 4 to the 5th power because I'm multiplying it 5 times. So I could do that, or I could also do, actually, we'll just do this. So that means that each of these, it won't do that. Sorry. I wanted to get it out of the parentheses and it's already in there. So we're going to just add another one. Okay, so I'm just going to type in 4. So this 4 has an exponent here. It doesn't show it, which means it's a 1. Because I am showing the 4, I have 1 4 there, so the exponent is implied a 1. That means I need to multiply this exponent into every single one of these, so I get 4 to the 5 times 1 is 5. Oops. Press the space bar, it gets us up there. And then x, I also have the implied exponent of a 1. 1 times 5, or 5 times 1 is 5. And same with the y. So we can see that the rule, I can multiply that in, which is the same thing as writing it out 5 times and then simplifying it by saying, oh yeah, I do have 5 x's, which is this way, but this way is faster. Then this entire thing is divided by x to the 3rd, and I have 2 ways of, I'm going to get that in there, and divide by x to the 3rd. There we go. So I have a couple of ways of simplifying this. One way is that I can separate these, and I show 5 x's here and 3 x's down here, and cross out x divided by x is 1, x divided by x is 1, and x divided by x is 1, which crosses out all 3 x's on the bottom, and I'm left with 2 x's on the top. Another way I can think about it is that I have 5 x's here and 3 x's down here, so I have 2 x's left over. Or you can subtract. So I guess I could have been writing that out. So I could have had 4, 1, 2, 3, 4, 5, and I could even write out the y's, but I'm going to do this right here. Raised to the, so the ones on the top, I have 5, and I subtract the ones on the bottom, minus 3, 5 minus 3. I could do that, and I still have y to the 5th. 5 minus 3 is 2, or, so I'm left with, oops, I forgot the power on the 4. I apologize about that. Then over here, I am left with 4 being raised to the 5th power. Then I have x being raised to the 2nd power, and y being raised to the 5th power. So there's a bunch of different ways I could go about that, but that's our simplified version. I hope that it's not asking us to go ahead and do 4 to the 5th. I'm kind of thinking that it wants us to keep it 4 to the 5th. We'll see. We'll see what Maple wants. 4 being raised to the 5th power times x being raised to the 2nd times y being raised to the 5th power, and we'll cross our fingers. Sometimes Maple's kind of tricky. We'll see if it likes it. Yep, it was okay. So let's move on to the next question. Question number 3. Identify the slope and the intercept of the linear function. So I got some of this up here already to remind us about the different types of functions. So the linear function, to differentiate between linear, quadratic, and exponential, linear is just x being raised to the 1st power. Quadratic means I have x squared. There has to be an x squared somewhere. If you have x beyond that, x cubed or to the 4th power or so forth, that's beyond our class. Don't worry about those. So as long as you have an x squared, that's quadratic. An exponential function, the x is somewhere in the exponent. So here are our standard forms that we will be working with in our class. The linear is this number here, mx plus b. This is slope-intercept form, m being the slope and b being the y-intercept. Right here is my quadratic. It's in standard form. A is the number before x squared, b is the number before just the x raised to the 1, and c is the coefficient without a variable. Then f of the third one, this is the standard form for an exponential. a times b being raised to the x plus c, and there's a few stipulations on this one, that b has to be greater, or if it is, it has to be greater than 0 and it cannot equal 1. So we'll just put that as a stipulation. B cannot equal 1 and must be greater than 0. So it's greater than 0. And I'm going to have to insert, you know what? Let's do insert an equation because I have don't equals there. B cannot equal 0. Okay, so those are a couple of stipulations. And a few other things that we could put down here. If b is greater than 1, it is going to be an increase. Sorry, some of the shortcuts on my screen recorder stop when I press the letter S. So it's increasing if b is greater than 1, and if b is between 0 and 1, so b is in between 0 and 1, then it is decreasing. Okay, so to get a number between 0 and 1, that means it's a fraction. So anytime you have a fraction right there, I'm going to have a decreasing exponential. So just a couple of those quick things. Let's go back to our question here, since I took a little sidetrack. Identify the slope and intercept of the linear function. Right here, by definition, this right here, the number in front of the x, is the slope. Slope meaning rise over run. Again, it paused for me. Sorry about that. So I have a slope of rising 4 and running 5. So if I were graphing this from one point, I would go, from that point I would rise 4 units and run 5 units. Up because it's positive, and to the right because it's positive. If the 4 was negative from whatever point I was on, typically the y-intercept, I would go down 4 units and to the right 5, because the 4 is negative and the 5 is positive, and you'll see that I end up with a slope that goes in this direction, a negative slope. So my slope here is the m, or 4/5, and the intercept, the y-intercept, is b, and I take with it the sign here, negative or positive, so my y-intercept is the -3. So my slope, I'm going to type in as 4/5, and the y-intercept is -3 on the y-axis. I guess we can verify how we did before we move to the next one, question number 4. So here we're actually going to be graphing some things, and I discovered that when we're graphing some quadratics, you have to do the vertex first, and so just a heads up on when you get to some of those. We're going to plot a couple of these ordered pairs. So the first coordinate in the ordered pair is in the x direction. I've had several students give lots of different ideas of ways to keep the x and the y direction, you know, kind of straight in your head. The one that I liked best was y is a tall letter. So when you think of y, this is the y-axis. And another way of thinking is x goes across. Like x is crossing itself, it's across, so x goes across, but y is the tall one. So here we're going to go 2, 5. So we're going to go in the x direction over to the right, +2, and then up in the y direction 5. And these aren't going to be exact, but they're close enough. Thankfully on Maple, it's good enough. It understands that it can't be absolutely perfect exact. Okay, the next one is the ordered pair 1, 4. So from the origin, or 0, 0, I go +1 in the x direction first, and then +4 in the y direction next. And we just try to get it as close as we can. Then the next one, -1, 8. So from the origin, I go in the x direction -1, and then it says +8, so I'm going to go up here 5, 6, 7, 8. There's my next one there, and it did my graph for me. Now it asks which of the following function goes through these 3 points. So I have 3 options here. I have a parabola, which is the quadratic. I guess I didn't put that in our little notes over here. First power, this is a line. A quadratic is a parabola. And the last one, this exponential, it looks, how would we, it's an exponential growth or an exponential decay. It grows increasingly larger or increasingly smaller. How would we describe that? Swoop? You know what? I'm going to leave that up to you. You come up with some mnemonic that'll help you remember that it starts out kind of slow and then gets increasingly larger, or it starts out slow and goes increasingly smaller, depending on if it's increasing or decreasing. So however you want to describe what that looks like. Okay, so because this is a parabola, I know it's a quadratic, so it'll be either the first option or the third option. To discover which of these works, I'm going to go through, any option I want. I could pick a couple of points, throw them in, and see if they work. So I could take even these ones right here, 2, 5. If I put 2 into here for every x and substitute finding f of 2, here I have 2. 2 squared would be 4. 4 plus 4 is 8. That doesn't work because it gave me the number 5 right here. So I know that's not working. That's a fast way of doing elimination. Another way I could do this, I would put the 2 here. 2 squared is 4 still. Minus 2 times 2. 4 minus 4 is 0. Plus 5 gives me 5. The answer is 2, 5. So this one I know just by plugging in this number right here and getting the 5 that is correct. Another way I could do this is to identify where these graphs either have a vertex and a y-intercept. The y-intercept is really easy. All I have to do is look at C, because the y-axis is here, and that's where x equals 0. So if I substitute 0 in on any quadratic in standard form, the 0 times a is 0, so it's gone. 0 times b is 0, so it's gone. 0 plus c just leaves me with c, and that's why that's the y-intercept. So I could look here, and the y-intercept for this one is at 4, the y-intercept for here is 5, and the y-intercept on my graph is 5, so I know it's this one. The other option is to go ahead and find the vertex for both of these, which is to find negative b over 2a. Here I don't have a term that has the x, so the b is a 0. So I have 0 divided by, it doesn't even matter, 0 divided by anything is 0. So that would be the vertex at, right here, the vertex at 0. And 0 is the y-intercept, and this does not have the vertex at the y-intercept. The vertex is down here at 1. To verify that, let's go ahead and find the vertex for this one. So negative b over 2a. Negative b is this negative 2. Oh, but it says negative b, so it's actually negative 2. So that's a positive 2. Positive 2 divided by 2 times a. I'm sorry, I'm not writing this down. If you would like to write it down, go ahead so you can have that visual. Maybe we should just do it. So I end up with negative 2 divided by 2a, and a in this case is 1. It's the number in front of x squared, which simplifies to be negative times negative 2 is positive 2, divided by 2 is positive 1. So the vertex, another way of thinking about it is kind of where I can fold this, and the vertex should end on positive 1 in the x direction, and I could fold that right there. To find the y coordinate of the vertex, I would plug 1 back into the function. 1 squared is 1. 2 times 1, or negative 2 times 1 is negative 2. 1 minus 2 is negative 1. Negative 1 plus 5 is 4. So I end up with the vertex of 1. Positive 4, which matches the point and the vertex. So we went through lots of different ways that you could go ahead and figure that out, or to graph it on your own. Lots of different things to work out on that one. You get to pick whatever you prefer when doing your homework, or your exam review or exam, or just drawing it out by hand. I guess I probably should have showed you that this one was correct. Okay, let's move to question number 5. Draw a line on the coordinate plane that has the same slope as the line shown below, but this line that we're going to do has a y-intercept of b equals -1. The y-intercept b right here in the standard or the slope-intercept form is this number right here. So we're going to go to -1 on the y-axis for the y-intercept. Again, remember y is the tall variable, so we're going to go to here, -1. Now I want it to be the exact same slope as this one so that they're going to be parallel. So I'm going to look at this and pick any point I want. It doesn't matter where I am, as long as it seems to be the line going through that exact point, because the slope will be the same no matter where I am on the line. From this point, I'm going to find another point on the line to find where I'm intersecting a nice even point so I can find the slope. So from here, I see this point and I see this point. To get from this point to this point, it looks like I'm rising 1 and I'm running 1, 2, 3. So it looks like I have a rise of 1 and a run of 3. But let's double check here. Let's go from this point. I rise 1 and I run 1, 2, 3. And remember, slope is rise over run. So in my case, I did 1 and I ran 3, so my slope is 1/3. The reason that's helpful to find is that from my point here, I can now go up 1 and over 1, 2, 3 to find the next point for my slope so that I can make these identical slopes. Let's verify that this was good and move to the next question, number 6. Draw both of the following functions on the coordinate plane shown below. The first function is in slope-intercept form of a line, so I know I'm doing a line, and I have the y-intercept is b and the slope is m. So on this line, +4, I'm going to go to the y-axis, the tall one, go up 4. That's where my first point will be. Now from this point, I can graph the next point using my slope, -3 over 5. So I can put the negative with the 3 or I can put it with the 5. It doesn't matter. It'll give me the same point no matter what, or the same line. So I'm going to put it with the 3. So when it says rise -3, that means I need to drop down 1, 2, 3. Now don't put a point here. I've had a lot of students try and put another point. We're not done yet. That's just the rise part of the slope. Now I need to run +5. Now some of you are going to say, wait a minute, there was a negative there, but we put the negative with the 3 and I only have one negative. So once it's with the 3, don't worry about it with the 5 because the 5 is going to be positive. So we went down 1, 2, 3. From here, I now need to take care of the run, which is +5. 1, 2, 3, 4, 5, and this is the next point on my line. Now I also mentioned that we could have put the negative with the 5. If I moved the negative down to the 5, the 3 is then positive, and that means I would run or rise +3. 1, 2, 3. And the negative being on the 5 means I need to go back or run -5 backwards. 1, 2, 3, 4, 5, and I could have gotten a point here. Either way, you can see that all 3 of these points, and no matter where I am on this line, if I were to continue doing this slope, I would get more points on the line. So from here I could go down 3 again, 1, 2, 3, and over 5, 1, 2, 3, 4, 5. There's another point on the line, and same thing from here. I could go up 3, 1, 2, 3, and back 5, and I'll get another point. Anytime, so it doesn't matter where I am on the line. However, because we get the y-intercept and that's so easy, that's where we start from to find the next point to draw our line. Okay, this next one right here is not in slope-intercept form. So the first thing I would do is solve for that so that it matches the slope-intercept form, and it makes it really easy to find those numbers really quickly for the rise over the run and the y-intercept. Let's go ahead, let's come down here just a little bit. So I have -x plus 10y equals 5. To put this in slope-intercept form, I want only y to be on the left-hand side and everything else to be on the right. So to get rid of this x here, I need to add x to both sides. So I know some of you are going to not want all of these steps, but I'm going to go ahead and put all of the steps on here so I don't lose anyone. So if I have negative x plus x, those can cancel out. They're gone. It's 0, and I'm left with only 10y on the left-hand side. And I'm going to put the x in front of the 5. I'm not going to do 5 plus x. I'm going to do x plus 5 because addition, it doesn't matter which one goes first. And the reason I'm doing that is that it'll follow the slope-intercept form of mx plus b. So the next thing I need to do is get rid of the 10 so that it's y all by itself. The 10 is being multiplied to the y, which means I need to divide both sides by 10. So we'll do it like this, divide by 10. And this entire side is also being divided by 10. But I have two terms over here. I can write it like this, which is also the same thing as dividing up those terms into two separate terms and dividing it by 10 both as well. So I'd get x over 10 plus 5 over 10. Either way is correct. I'm going to go with the second way though because that gets me closer to the slope-intercept form. So 10 divided by 10 is 1, or they cancel out. You can think of it as that, which leaves me with y, or 10 divided by 10 is 1. 1 times y is y. Either way you like to think about it, I'm only left with y on the left-hand side of the equation, or the function. Then I equal x over 10 plus 5 over 10. Now the coefficient in front of the x, there's nothing there, which means I can automatically assume there's a 1. So 1 divided by 10 is 1/10 x. And then 5 divided by 10 is 1/2. Simplifying the 5 over 10 simplifies to 1/2. Now I'm in slope-intercept form. I can go ahead and go to my my graph over here and find the y-intercept of 1/2, and then I need to draw. Go to my 1/2 here, and if you're not happy with something you can always delete it here as well. So 1/2 in the y direction, that's the y-intercept. Now I have a slope of 110. That means from this point I can go rise 1 and run 10. So that was positive 1, and then running 10 to the right because this is the positive direction. And I can even use my squares here. I can see my scale goes to 10 here, so I rose 1, which goes from 1/2 to 1.5, and run 10 right here will be my next spot. And there we go. We got our two equations or functions graphed, and we can just verify that and move to the next one. Question number 7. Draw the graph of the following quadratic function. So we've drawn some quadratics before. We have lots of different options we can do. The first thing I'm going to, Maple, I discovered previously, wants the vertex first, and then you can go through the y-intercept. If you do it the other direction, it gets kind of confusing. If you're graphing by hand, it really doesn't matter which one comes first. But I'm going to do it both ways so that you can kind of see what the error is when you do it backwards. When I originally did this, I thought, hey, I'm just going to find the y-intercept because it's very easy. If you plug in 0, these two terms cancel out. There's nothing there, so it's plus 5. And so I went to 5 and I said, there's the y-intercept. And then I found the vertex, or no, I think I just put in a number. Putting in a number like 1, because 1 is easy and small. 1 squared is 1, 1 times 3 is 3. 1 times -6 is -6, so 3 minus 6 is -3. -3 plus 5 is positive 2, so I get the point 1, 2. That was really fast, and you'll, if you'd like to slow that down and go back or write it all out, that's fine. But let's just say that I did all of that correctly. You'll notice that this parabola is facing downwards, and this right here is a positive 3, and that should mean that it is opening up. So it's just a Maple TA thing. These 2 points are correct for this graph, except that Maple TA drew my graph downwards. So the first thing I need to do is find the vertex and then the y-intercept when graphing this. So let's delete these guys. Those 2 points are correct though, so it's just a matter of putting them in a certain order on Maple TA because it's kind of quirky. So what I want to do is find the vertex. To find the vertex, it's negative b over 2a. I'll get rid of this work from my last one. And we're going to find b is negative 6. So it's negative 6 because it's negative b, divided by 2a. A is the number in front of the x squared, which is 3. So I end up with negative times negative 6 is positive 6. And 2 times 3 is 6, so it ends up being 6 divided by 6, which is 1. And I already plugged in 1 previously, but we'll go ahead and do that anyway. So once I find the x coordinate of the vertex, I put this number back into here and solve to find the y value. And I'll go ahead and slow down and do the work over here. When I want to find a function at a point, I always put parentheses around every single x that I get to. So 3, and then there's an x, so I'm going to put parentheses, substitute in the 1, and then squared, minus 6, there's another x, so put parentheses. That way I know that I'm going to be multiplying those and it doesn't look like it's 61 or something like, oops, not x, I meant 1. So if you didn't put the parentheses there, you might forget that that's 6 times 1. Or if it's a negative, some people start subtracting and that makes a mess. So just make sure you get your parentheses around that. Okay, using the order of operations, we do 1 squared first. Please excuse my dear Aunt Sally, or PEMDAS. So exponents come before anything else. 1 squared is just 1. So I end up with 3 times 1 minus 6 times 1 plus 5. Some of you might be frustrated to be going so slow. Go ahead and skip forward in the video while I do all of the calculations. I just don't want to lose anyone who might not follow my mental math. 3 times 1 is 3. Oh, and please excuse my dear Aunt Sally, the next thing we do is multiply. So I need to multiply the 3 times 1, which is 3. I need to do 6 times 1, which is 6. And then 5 had nothing operation over there. So then I add and subtract from left to right. 3 minus 6 gives me negative 3. Plus 5 is negative 3 plus 5 is 2. And so I have the vertex at 1, 2, which we already graphed before in Maple, but I graphed it second, and that's why it did something weird on me. Oh, I need to click that I'm graphing 1, 2. And I had my y-intercept, it's that very last number, 5. And you'll see in flipping those, it made my graph go upwards. It's just a weird Maple TA thing. Even though we had those graphed before, because I did them backwards, it flipped it around. Anyway, so that one looks good. And if you're not sure, I always check, make sure that it's opening the right direction. And that was one way to make sure. Okay, it's always nice to see that little green check mark. Okay, the next one. Find the vertex, y-intercept, and direction of the following quadratic function. Well, it's similar to what we just did. So the x-coordinate of the vertex is going to be negative b over 2a, just like we did. And I'm going to come in here, and those numbers are rather similar, so I'm going to delete to here and just throw in some information. Negative b, it's a positive 6, so that's negative, and then positive 6 divided by 2a. Here a is negative 3, so I have negative 6 divided by 2 times negative 3 is negative 6. Negative 6 divided by negative 6 equals a positive 1. So my vertex, the coordinate is 1, comma something. We'll go figure out the next part. The next one, we'll put the 1 into the formula, or the function f of 1 now. And every time I see that x is when I'm going to put parentheses around whatever I'm substituting in. So I have negative 3 times 1 squared plus 6 times 1 plus 4. And then using the order of operations, exponents first, 1 squared is 1. So I am left with negative 3 times 1 plus 6 times 1 plus 4. Order of operations next is multiplying from left to right. So negative 3 times 1 is negative 3. Positive 6 times 1 is plus 6, and then, or positive 6, and then plus 4, no operation to do there. And then add and subtract from left to right. Negative 3 plus 6 is positive 3. 3 plus 4 equals 7, and so the y value of my vertex is 7. The next thing is to find the y-intercept. The y-intercept on quadratic is just this last number, c. Another way of thinking of that is that if I put in 0 for x, it'll cross the y-axis, so 0 makes this term 0. 0 times this, whatever it is going to be 0. So this last term right here, including its sign, will be the y-intercept. So this one's going to be positive 4. Okay, so we can type those in. We have 1, 7, and positive 4. And we look at the front of this. It says negative 3. That tells me that this, I know this might be silly, because these are parabolas, sometimes we think of it as being a smiley face or a frowny face, and this is a negative, so it opens down. It's a frowny face parabola. If it's positive, you have a happy face and it opens up. It's a silly mnemonic and silly way to remember that, but for those of you who like those mnemonics, that'll be helpful in the future. And if it's silly, you'll probably remember it. Okay, question number 9. Graph the exponential function f of x equals 3/2 times 4/3 raised to the x minus 1. I'm going to delete some of this so that I can get my information back up here for my exponential function. Okay, use the following to help you plot the function. When x equals 1, f of x equals something. So here's my function of exponential a, b, c. B has to be greater than 0 and cannot equal 0. Those are just stipulations. You won't run into anything about the definition. Let's come down here, and it just wants us to find when x equals 1. So we'll just substitute it in. So I have 3/2 times 4/3 being raised to the first power minus 1. 4/3 being raised to the first power, it doesn't change anything, so I just end up with 3/2 times 4/3. You know what? Because we have the magic of doing this in a computer, we can just copy and paste, and evaluating it, it becomes 4/3. And we did that first because of the order of operations. Now we go ahead and multiply, and we can multiply these fractions several different ways. We can multiply straight across. So we get numerator times numerator, which is 12. So that equals 12 divided by denominator times denominator is 6. And then we still have this minus 1. I actually prefer reducing beforehand, simplifying the fraction beforehand by doing 3. If I have a 3 on the top and a 3 on the bottom, I can reduce that already by dividing. 3 divided by 3, some people divide that and say it's 1. I say it just cancels out, so I cross those out. Then 4 and 2 are both divisible by 2, and that leaves me with a 2 here. Oh, you can't really see it's crossing the 4 out, but this leaves me with a 2. And so if I were doing this by hand, I would cross that out and put a 2 here. So I'm left with 2 minus 1. Or you can multiply and then simplify, which is 12 divided by 6, which is still 2. 2 minus 1 equals 1. So plugging 1 into this equation gives me a 1. The y-intercept of the function is, the y-intercept is a plus c on these ones. So I'm going to come here and find a plus c. That's 3/2 minus 1, because this negative goes here with it. Another way of thinking of 3/2 is 1 and 1/2. 1 and 1/2 minus 1 leaves me with 1/2. So this is 1/2 right here. If you're not comfortable with that, you can type in 3 divided by 2 and get 1.5, subtract 1, and put 0.5. And both of those, I believe, are okay to put in here. In Maple T8, it understood that 0.5 and 1/2 are the same thing. The horizontal asymptote of the exponential function is at y equals something. The horizontal asymptote for exponential functions is just that last number, y equals c. And because I have a -1 here, that asymptote is at -1. Okay, so now we're going to graph these. The number, or the coordinate point 1, 1. So from the origin, we always start here, move +1 in the x direction, and then move +1 in the y direction, and that's where our first point will be. And it's prompting you in the order that it would like you to graph these, so that Maple TA knows how to graph it, just like the last one with doing the vertex first. The next thing is to find the y-intercept of the function is 1/2. That's where it's crossing the y-axis, here at 1/2. It's close enough. And then the last one, the horizontal asymptote of the expression is at y equals -1. So anywhere along this line, the horizontal, this is where y equals -1. Every single one of these points, -10, -1, -5, -1, 0, -1, 5, -1, all along here is where y equals -1. And you can press anywhere so that it can see that that's your horizontal asymptote. And if we'll go ahead and say, how did you do? So we can have the reassurance that it is indeed correct. Okay, question number 10. Oh, I'm going to come back to that in just a second. Okay, I just had to get a couple of things set up over here in Excel just to make things go faster. It's dramatically faster if you just use Excel on this one. Okay, so Bryce is flying to Salt Lake City to visit his grandmother. He will arrive at night and rent a car to drive 26.5 miles to his grandmother's house. He will spend 3 days with his grandmother and then drive 26.5 miles back to the airport to fly home. Bryce has budgeted $235 for his rental car. Or his car rental, sorry. Bryce and his grandmother want to visit a different destination each day, so every 3 days there's going to be a different destination from the list below. He needs to decide which destinations they can visit and still keep the total car rental cost inside his $235 car rental budget. The car rental fee for the vehicle Bryce wants is $39.25 per day. And he's going to be there for 3 days, right here. Also, there is a mileage fee of 43 cents per mile. He has researched on the internet about the car and the area. He assumes the rental car gets about 32 miles per gallon and the gas costs $2.88 a gallon. Okay, so step number 1, create a linear function that uses the number of miles driven as the input and provides the total car rental cost, including the gas, for Bryce's entire trip as the output, because we want to see how many miles we put in and what the cost is to come out. To find the slope of the linear function, compute the cost per mile by adding the mileage fee and the cost of gas per mile. Hint, to find the cost of gas per mile, divide the cost per gallon and the miles per gallon, and the gallons unit cancel, leaving the units dollars per mile. Okay, so we're going to do a little conversion here. I've written everything down that I could glean from this to use in Excel, and we're going to find the cost first, 32 miles per gallon, and we have dollars per gallon. Okay, so we want to, I'm going to pull up something else. Okay, I just wanted to show my work here by bringing up Microsoft Word. Okay, so the hint it was giving us is dividing the cost of gas per mile divided by cost per gallon. Find the cost of gas per mile by taking the cost per gallon divided by the miles per gallon, and the gallons will cancel using our unit conversion stuff. So I want $2.88. It was $2.88 per gallon. So per means divide per. Sorry about that. It pauses every time I type in A. Okay, so cost per gallon. And then I need to times by the next one, which is, I need another one of these in here for my conversion. So if I have gallon on the bottom, I want to get rid of gallon on the top. So I'm going to put gallon up here, or 1 gallon, same difference. And then it was 32 miles per gallon. So 32 miles. And then the gallons will cancel. So one way of showing that is to cross these out, strike that out, whoops, strike this out, and I'm left with cost per miles, which is exactly what I wanted, because we were already given cost per miles with the mileage fee of 43 cents, and I can add those and that'll give me the total cost per mile in the driving. So I need 2.88 divided by 32, and I'm left with dollars on the top and miles on the bottom, and we can go ahead and use Excel over here to find that for us. So we're going to do equals 2.88 divided by 32, and that gives me, oh, it doesn't understand miles per gallon, so let's erase miles per gallon. Just type in the 32 gas. We'll do miles per gallon here so that we know that. And that gives me about 9 cents. I'm guessing that that's, we could go out a little bit further. Nope, just 9 cents. That's great. Okay, so this is the cost per mile in gas. Cost per mile, and we need to add that to the cost per mile here, which is 0.43 per mile, and that tells me this number, how many of what I need to times by miles driven. So we have mileage cost, which was 43 cents right here. Oh, per mile, there we go. So we can just do total cost per mile. Okay, it keeps pausing on me. Cost per mile, which is going to be this plus this. And that gives me my 52 cents times however miles I end up driving. But then I have this flat number. Do you remember that we're going to be spending exactly $39.2 per day? So that one's going to be how much I'm going to be spending for the entire the trip, 39.2, and we are going to be there for 3 days. So we'll take this number and times it by 3 days, which gives me $117.75, and that's the flat cost of having it for the 3 days. This one's going to be the variable cost that it's going to change depending on how many miles I drive. So we're going to put in here 0.52, and over here 117.75, and we're rounding to the nearest dollar or cent. Okay, moving to the next step. Use your function above to determine how many total miles Bryce can drive and stay within his $235 budget. So we're going to solve this function here, f of x equals 235, and see how many miles, and we'll call that x, or x right here, and see how many we get to. So we can do that here. We can do it, let's bring up Word again. Okay, so we're going to find f of x being 235 equals, using this function that we just came up with, 0.52x plus 117.75, and to solve for x we're going to subtract 117.75 from both sides, so minus 117.75, and this side as well we'll just show that I'm subtracting 117.75 0.75. So on the right hand side, these cancel out to 0. On the left hand side, I get 235 minus 117, and I'm just going to do that here, equals, oh, and I even have these numbers, so I'm just going to cell reference those, equals 235 minus 117, because it's super fast, and that gives 117.75, and I get 117.25. So, whoops, went too far. There we go. So on the left-hand side, I am left with 117.25 equals 0.52x, and the 117.75 cancel on this side. Okay, so the next thing I need to do to solve for x is continue getting rid of everything on this side. This 0.52 is being multiplied to the x, so I need to divide both sides by 0.25. Or 0.52, sorry. So over here, 0.52 divided by 0.52 is 1. 1 times x is x. So the only thing left on this side is x. But I also need to divide this side by 0.52 to keep it balanced. And I'm going to do that here. Equals this number, divide by 0.52, the benefit of using Excel. And that gives me 225.48. And this is giving me numbers, or dollar, and I don't want it to be a dollar because this is representing miles, and it was just doing that because I cell referenced money over here. So I'm going to get rid of that just so it doesn't confuse anyone. We are dealing with 225 miles, and get down here again. So I have, dividing those is 225.48 equals x. X is the number of miles we can go, and this says round it to the nearest whole mile. 4 does not round up the 5, so it's just 225. So we're going to put in 225. Okay, the next one, find the total number of miles Bryce would drive, including to and from the airport, if they visited Lavelle Edwards Stadium on the first day, Park City Mall Outlet Mall, and Olympic Park on the second day, and Grandeur Peak on the third day. So we're going to go up here and find each of these, and we need to make sure, including driving to and from the airport. So to and from the airport is, you know what, let's delete these now that we've found this information, and we're going to come over here. We're still in number 3, so let's just put number 3 and then we can get some of these calculations in here. We want to find the total number from the airport, and I wrote that down over here as well. From the airport is 26.5 miles. So we need to go to and from the airport, so we need to double that, including to and from the airport. So we're going to do equals. To and from the airport is this number times 2. And what else are we going to do? We want to find the total number of miles airport if they visited Lavelle Edwards Stadium. And because we're not just going to go there one direction, we're going to go there and get back to Grandma's house. So we're going to go to 53 point. So we're going to add this, and we want to get back. So times 2. If you were doing this on your own, maybe type in the double numbers. Then you wouldn't have to times by 2 both times. Lavelle Edwards Stadium. Okay. Park City. So we have Park City here. Oh, I forgot to press add. Add Park City times 2. And then add we have Park City Mall and Olympic Park. So I'm guessing we're not going back to Grandma's house. So let's do Park City and Olympic. So we're not going to times by 2 on those ones. I apologize on that. So we're going to go to Park City. You know what? I don't think we can specify. I apologize. I think we have to say that we're going back to Grandma's house. So, because there's no way of knowing how far it is from Park City. Oh, we're on this one. Park City Mall Outlet and Olympic Park on the second day. You can't specify. We're going to have to go back to Grandma's house. So we're going to do Park City Mall. And just double check my numbers here. Oh, I'm so silly. I just realized I abbreviated Park City Outlet Mall and Olympic Park is one trip. It's not two different destinations. I apologize. That was so my mistake in reading that. Okay, so we went to the park. I just didn't type the whole thing out. Park City and Olympic Park is the same thing. And going back to Grandma's house times 2. I'm sorry if that caused any confusion. And Grandeur Peak on the third day. So then we go to Grandeur Peak. And, oops, I need to add that. Oh, it's good for you guys to see that the teachers sometimes go crazy too. Grandeur Peak times 2. Okay, and we got back to the airport because we times it by 2. Double checking just to make sure I got to Lavelle Edwards Stadium. Yep, and I times it by 2 so we could get back to Grandma's house. Park City Outlet Mall and Olympic Park is all the same location for the second day, times by 2 because we go back to Grandma's house. And the third day, Grandeur Peak, and we get back to Grandma's house. All of those make the total number of miles of 282. Okay, so then we'll type in 282 over here. And the last one in question number 3. Use the function you created to find the cost of travel to and from the airport, Lavelle Edwards Stadium, Park City Mall Outlet, and Olympic Park, and Grandeur Peak, which we just found how many miles, and so we can just plug that into our function. That is this 0.52 times miles driven equals 117.25. So I'm going to come over here and we'll give ourselves the cost. And this is going to be equal 0.52 times the miles driven, add 117. I'm actually just going to cell reference, so I deleted that one, so I'm going to have to write it 117.75. And we end up with a cost of, to the nearest whole dollar, not the nearest cent, 2.6, and the 3 does not raise the 4, so 264. I probably should not have erased my 117. That was my mistake. The last thing is, would this trip fit into Bryce's rental car budget? His rental car budget was $235, so nope, this one does not work. Alright, the next one, and you'll see why I came up with this huge spreadsheet over here. Well, not huge, a larger spreadsheet for this question, because we have 6 different options, and we're going to write them all down, and hopefully it'll be really fast to find the answer. So, in fact, I'm going to come over here and I'm going to get that 117 up again, so that I can just reference that. We needed equals, it was on this line, equals how much he is there times 3 days. There we go. Okay, now I can reference that again. That's after 3 days. Okay, so here for option 1, we're going to do Grandeur Peak. Oh no, option 1 is Park City. I'm going to reference this. And then he's also going to Grandeur Peak, which is this one. And where else is he going? Lavelle Edwards Stadium here. Okay. The next one is Park City again. Actually, several of them are Park City, so equals Park City. And the next one is the Hochul Zoo, equals the Hochul Zoo. And the next option is Lavelle Edwards Stadium here. Option 3, if you want to fast forward the video a little bit, you can do that. Park City again. This one is Grandeur Peak. And the last one is, we're on option 3, Temple Square, which is here. Okay, and then option 4, Park City, again, Park City, he must really want to go there. And then the second place, option 4 is Temple Square. And then option 4, third place is the Hogle Zoo here. And option 5, Grandeur Peak. Option 5, second place, Temple Square. And again here, the Hogle Zoo. Whoops, 2 of those, the Hogle Zoo. And option 6, Park City. Then Temple Square. And the last place is the stadium. Okay, I got all of those, which gives me a total mile distance. I'm gonna do my auto sum, which is super fast. There we go. And then I want to find the miles for all of them, and that's why Excel works so nice on things like this. Okay, so now we have the total miles, and we can go ahead and find the total cost for each of those very quickly. Let's see, enter the option number into the blank. Oh, we need to find out first. We need to be within the mileage requirement for step number 2. So we need to be under 282. So I know, oh, whoops, we forgot to add in here, going to the airport. We need to get to and from the airport. So this is not the exact total. We need to make sure that we get to and from the airport, which is equal the airport and back to the airport, and then add my total from all of the activities. I apologize for that. We need all of those added in. There we go. Now we can get back to the airport for each of those. Oh, whoops. I did not specify to always absolute cell reference the airport. If you wanted to just type that in, that's fine too. Okay, so now I need to go back and find my cost and see if I can get something under 235. So for each of these, we can type in our function again, which we have up here, 0.52 times the number of miles, and then add my 117, and I'm going to absolute cell reference this one so I don't forget. And let's see, did everything else work out? Yep, it looks good. Okay, so then I can click and drag and find the total for all of my vacation. Just double check that that's working. Okay, so come down here, enter the option number that will get us below 235. I have lots of options. I knew there was something wrong. Okay, we did not go back and forth in each of these. These totals need to be multiplied by 2. So make sure that we get back each time for each of those, which doubles the mileage. There we go. That makes it look so much better. Okay, because you know what? On yours, I really would make sure that you get the round trip on there instead of the miles to Grandma's house. That would have saved us a lot of time. Okay, so now we're going to look for miles under 282 or the dollars that are 235. So let's see, is there any options? We have this one, this one, this one. So we have, I think we have these 3 options here, right? Yep, those are all under 235, which is his budget. So you have 3 options you can pick from, and so let's put in option number 5. Sure, because it fits. And then the last one, use your function to verify that the trip you selected fits within the, yep, we already did that. We did it over here. And let's go ahead and, how did I do, just to make sure that we got it all good to go. with a couple of my errors. I apologize, but that's good for you guys to see that there's a good way to troubleshoot some of these things, and that if something doesn't look right, to second guess yourself on that one, like when all of those fit. That doesn't make sense that all of them would have been the case. So went back and did some troubleshooting. So I think that's actually beneficial for you to see that if something doesn't look right, to go back and fix it.